I will start. Thank you, Alice, for the nice introductions, and thank you for everybody joining my talk today about the Cornerstone software. Cornerstone software is a workflow-oriented data analytics tool, and my name is Kezhen Wang. I go by Jenny. I am a statistical consultant at camLine in the Cornerstone team, and I am involved mostly in developing new features for Cornerstone and also in helping with some of the training activities. And first is some background about camLine. camLine is founded in 1989, and since then we have been providing reliable software solutions to more than 250 customers across more than 40 countries. We have more than 350 colleagues in 13 offices across the world. And for our customers are primarily in the semiconductor industry, but some others are also in automotive, medical devices, and renewable energy. And in 2021, camLine joined the ELISA industry company. And then since then, the parent company has provided us with more resources to advance our software solutions. And so today I will be talking about the Cornerstone software. But camLine also have other software solutions. For example, the Line Workspace, which can create statistical process control plot. And then use the LineWorks DXM, which stands for the Data Extraction Manager. And one can link the data from Line Workspace to Cornerstone to do any further data analysis. And then also you can link the LineWorks RM, which stands for Recipe Management, also to Cornerstone to do data analysis. And so here is the overview of the core functions of Cornerstone. You can use Cornerstone to visualize big data in various graphs. You can also do a regression analysis, sensitivity analysis, and fit various distribution to your data. And you can also create a process capability plot. And then all of these functions can also be coupled with this design of experiment module, which helps you to create an optimal design space of your experiment. And so other functions also include multivariate ANOVA, principal components analysis, and also you can create various summary statistics to have a better overview of your data, and also create a statistical process control chart. And in addition, there are also two other modules that can be very useful. For example, the Cornerstone extension language can allow you to automate all of these analysis that you do in Cornerstone, and also a Cornerstone R extensions that allow you to do more complicated statistical modeling through R. And there are many useful tools in Cornerstone, and these two features really stands out. First is this work map concept, which allows you to track all of your analysis, including the charts, the tables, to your original data. And then you can use the brush mode to highlight specific area in the linked objects, for example, in the graphs. And then those data points will be highlighted in all the graphs and tables that are linked to each other. And here are some examples of the basic graph you can do in Cornerstone. And you can also do more advanced graphing in Cornerstone. For example, you can create a multi-category chart. And then here, you just simply highlight the column that you want to include in the chart, and then click the icon in the menu, and then you have this multi-category chart. And then you can use the brush tool to highlight specific area. For example, here, I highlighted the Wednesday in day of week, and then we can see that in this state, there is more shift in the afternoon compared to the other time, the other shifts. And then you can also create a parallel coordinate plot. And then here you can use a different method to select the column, the variables you want to include in a dialog. And then again, in the graph, you can use the brush tool to highlight the specific area in your data to see how the values are connected to each other. And you can also combine two graphs very easily. Here, I just simply copy paste the scatter plot onto a histogram. And then I added a second y-axis to the right. And also on the graph, you can directly fit a linear regression just in the graph. So it's very easy to create a graph, to copy paste and combine graph. And then there are also other types of graph, but I will not go into detail. And then in the next slide, I want to show you some examples of doing analysis using Cornerstone, and they are principal component analysis and regression. And the principal component analysis basically summarizes most of the variations in your raw data into fewer variables. And it can simplify any follow-up analysis by using a smaller set of uncorrelated variables. And it's very helpful to review any patterns in your data. For example, you can see whether there is a clustering effect among the variables. And then regression analysis is used to model the relationship between the response and predictors. And it can help you to examine the significance of this impact of the predictors on your response. And in Cornerstone, you can very easily to directly investigate how those changes in the predictors will affect your response. So principal component analysis, basically, it concentrates those most of the variance in your data into these fewer representative of the original variables, and they are called principal components. And here I will use a sample data set to demonstrate how this analysis is done in Cornerstone. And this data set is for a cement mixture. And then, but here I do want to note that this is just a simple data set for demonstration. But Cornerstone is actually primarily used in the industry of semiconductor, renewable energy, of batteries, and also advanced materials. And then, but here, I saw that this is a small data set, and then but tells a very nice stories. So in this data set, the first few columns includes the chemical compounds and some materials in this cement mixture. And also the last columns is the heat generated during the curing process, which is a hydration process in cement. And I will do a principal component analysis on the first column of data. And then, so the result in Cornerstone will be four principal components or PCs corresponding to four original variables. And then in the table, it's very hard to see what those values represent. And then, however, Cornerstone will also directly show you the variance explains by these principal components. And here we can see the first two PCs or principal components explain more than 90% of the variance. And there's also another very important property of the PCA results. While the original variables are likely correlated, the PCs are actually linearly independent, which is a very important properties for any follow-up linear regression analysis. And in Cornerstone, along with the principal components, you can also see the loadings or the weight of these principal components. And here in this result, each row represents a principal components, and the last four columns are the loadings or the weight. And then here you can see the variance explained by each one of the principal components. And then, so here's the formula for the first principal component, PC1, and which is actually a weighted sum of all of the original variables. And then in Cornerstone, you can also have a look at the loadings graph. And then here is a loadings graph for PC1 and PC2. And then if you have a closer look into the value, and these two compounds that include aluminum actually has the weight of it, the magnitude are very similar, but they have different signs. And then the same story goes to the compounds that contain silicon. And then they all have a similar magnitude, but have different signs. So we can approximate the previous formulas into a weighted sum of the differences between these pair compounds to represent PC1. And then since we know that PC1 contains most of the variation of the data, so we can interpret the result such that the variance of the data actually comes from the differences within pairs of compounds. And then we can, this is the formula for PC3, which is similar, also a weighted sum of the original variables. And then again, we can take a look of the loadings graph. And then here it's the loadings graph for PC3 and PC4. And here it tells a little bit of a different story. For the compounds that contain silicon, it has a similar, the loadings are similar in both the magnitude and the signs. And then same for compounds that contain aluminum. And then so we can again approximate the formula for PC3 into a weighted sum of some of these paired compounds. And then we know that PC3 contains very little of the variations of the data. So we can interpret the results such that even though the individual compounds are varied, but the total amount of these paired compounds are actually relatively constant. So I thought that this is a very nice examples to show that how PC1 can really review some patterns of your data to help you have a better understanding of your system. And then next, we want to see how these principal components affect the heat variables. Heat is usually generated when the water is added to cement. And it's very important to manage this heat variable because large heat variations can cause thermal crackings, and high heat will negatively affect the strength and durability of the concrete. And then we can also very easily plot a variable graphs in Cornerstone. Here I plot the variable heat onto PC1 and PC2. And we can see there's a very strong positive relationship between PC1 and heat. And then we can feed a linear regression on this data set. And then here Cornerstone will show you the significance of each term. And then we can see that the significance for PC1 and PC3 are very high. And then we can also take a look at the coefficient table generated by Cornerstone. And then we can see that all these terms has a positive impact to the heat. And then previously, we also had an inside look of what these PCs represent in the data set. So that also gives us an insight how those variables are affecting the heat. And so this is a fairly simple examples for linear regressions with only 4 terms. And then in the next examples, I want to show you a more complicated examples of regressions at Cornerstone. And these examples is on wafer uniformity. And then the goal of these examples is to maintain a uniform features on a wafer during etching process. The etching process is a step of the semiconductor manufacturing that is used to remove certain materials of the wafer. And then in these examples, a contact hole is etched away before conductive material is filled in later. So in the graph to the left, you can see a schematic of this contact hole. And then also all the factors that's involved in the etching process. And the goal is then to have a specific size at the top and bottom of the contact hole. And then the measurements should be consistent over the wafer. And then in the graph on the right, you can see the 15 positions where the data are collected. And that's what the data looks like. The first few columns, it shows the factors that's involved in the etching process. And then there are some reactive gas and pressures and temperatures. And then you can also see the data of the positions on the along the X and Y axis. And then the last tools are these contact hole distance, the gap. So they can be used as the response of the linear regression. And for demonstration, I will only use the CD top as a response, and the rest will be the predictors. And then I feed a quadratic regressions to model the relationship between CD top and the predictors. And you can see that the model can get more complicated here. And in Cornerstone, you can also open the predictive response graph to help you to see how the predictors affect the response individually. And in this predictive response graph, the x-axis, they are the predictors, and the y-axis is the response, which is CD top. And then also you can have a reference line to point to a specific area, a specific value of your predictors. And then each graph to shows, it's showing how the response is linked to a specific predictor value. And then we can see that in the last two graphs, and here shows the measurements along the X and Y positions. And then we can see that it's not very uniform. It's not a flat line. So that's not the scenarios that we want. But if we move this reference line from the left to right for this specific factor, and then we can see that the measurements of the top of the contact hole become more uniform, more flat across the X and Y positions. So in Cornerstone, you can very easily have a look at how the predictors will affect your response. So that was the end of some examples of the analysis. And then I do want to remind you of all the other functions that we have at Cornerstone. And also this design of experiment module in itself, it's quite a large modules. And then that also contained different algorithms and then different methods and design types for you to create an optimal design space. And also the Cornerstone extension language allows you to automate the analysis, which can be useful in testing your systems, equipments. And then Cornerstone R gives you more freedoms and also allows you to use more advanced statistical models from R. So now I would like to give you a very short demo of what Cornerstone looks like. I already have it opened here. So here it's when you open Cornerstone, it will be empty. And then now I have already loaded a data set here. This is the segment querying examples that I already mentioned in the slides. And then here I want to apply a principal component analysis, and then we can find that we can select the analysis on the list. And then I select these four variables. And then directly we can see the variance explained by all the principal components. And then here, then I can have a look at the components values. And then also the loadings, as I have shown in the slides. And then on the graph, I can have a look at the loadings graph. I will use an example for PC1 and PC2 right here. And this is also a graph that I've shown in the slides. And now I like to go back to the work map to show you how they are linked to each other. So this is the concept in Cornerstone that can be very useful. You can see how this analysis that's linked to which analysis and which data set. You can also load many different data sets at the bottom. And then now I also want to then fit a linear regressions to the PCs. But here I only have the predictors, not the response. But since these two data are linked to each other, I can then also edit that column very easily here in the data set. And then I can fit a linear regression by using the four variables as predictors, and then here as response. And then here, Cornerstone will show you the significance of each terms. And then we can explore in depth into the data to see, for example, what the coefficient table looks like, and also goodness of fit. And then graphs here, again, you can also explore these graphs that's connected to this model. And then again, everything will be linked to your data, and then to see the workflow of your analysis. So here it's a small demonstration, and then that will also be the end of my presentation. I we're always happy if you want to know more about Cornerstone, we're happy to also give you a more detailed demonstration. So if you would like to reach out to us, we're happy to show you more about Cornerstone. Thank you. Now I'd like to take any questions you may have.